Hello and welcome to InsideWi-Fi, Video 49A. The anatomy of a Legacy OFDM PPDU. Every time you send a file over Wi-Fi, whether you're using Wi-Fi 4, 5, 6, or even the latest Wi-Fi 7, you are relying on a foundation built decades ago. This foundation is the Legacy OFDM PPDU. Originally defined in 802.11a and 11g, this frame format is the universal handshake that allows modern routers to talk to old devices, and more importantly, allows different generations of Wi-Fi to coexist without crashing into each other. The classic sequence of the Legacy OFDM PPDU format is L-STF, L-LTF, L-SIG and data, where this is referred to as preamble section 1, L-SIG section 2, and data section 3. Section 1, the preamble or the handshake. Before a single bit of your data is sent, the transmitter and receiver need to get on the same page. This happens during the PLCP preamble, a 16 microsecond window split into two critical parts. 1. Legacy Short Training Field L-STF. Think of the L-STF as the wake-up call. Lasting 8 microseconds, it consists of 10 identical short symbols. Because these symbols are repetitive and predictable, the receiver hardware recognizes them instantly. Packet detection. Hey, something is vibrating at 5 GHz that looks like Wi-Fi. AGC adjustment. The radio automatically adjusts its gain, so the signal isn't too loud and distorted, or too quiet and lost in the noise. 2. Legacy Long Training Field L-LTF. Once the receiver is awake, it needs to focus. The L-LTF provides the fine-tuning. It uses a double-length guard interval followed by 2 long symbols. Channel estimation. By seeing how these specific symbols were distorted by walls or interference, the receiver builds a mathematical model to undo that damage for the rest of the packet. Section 2. Legacy Signal Field L-SIG or the Instruction Manual. Now that the radio is tuned, it needs to know how to read the message. This is the job of the L-SIG field. It's only 4 microseconds long, but it is the most critical part of the frame, the PLCP header. Because it's so important, it's always sent using the most robust settings, BPSK modulation, ensuring even a weak connection can understand it. Inside this 24-bit field, we find rate and length. It tells the receiver exactly how fast the data is coming and how long the transmission will last. Coexistence. This is the magic of Wi-Fi. Even if a Wi-Fi 7 laptop can't understand the high-speed data inside an old packet, it can read the L-SIG. It sees how long the channel will be busy and sets its network allocation vector, NAV, to stay quiet until the transmission is over. Section 3, the data field or the payload. Finally, we reach the reason the frame exists, the data field. While the preamble and SIG are overhead, the data field is where your email or video stream actually lives, which is the PSDU. The data field handles 3 main jobs. Transporting the MAC frame, it carries the source and destination addresses and the actual payload. Maintaining sync, it starts with a service field to seed the descrambler, and uses pilot subcarriers, small beacons of known data, to ensure the transmitter and receiver stay perfectly locked in sync even during long transmissions. Adaptive speed. Unlike the preamble, which is always slow and steady, the data field scales. If you're near the router, it jumps to 64 QAM, 54 megabits per second. If you're far away, it drops to BPSK, 6 megabits per second, to stay reliable. Summary, the flow of a packet. To recap the journey, L-STF or L-LTF, get ready. Tune your radio. L-SIG, I'm going to talk at 24 megabits per second for 1000 bytes. Don't interrupt. Data, here is the message. That is the beautifully efficient design of the Legacy OFDM PPDU, the heartbeat of wireless communication. In our next video, let's see about the 802.11n PPDU. Thank you for watching.